Picture this. 40,000 years ago, the sun is gone. The temperature outside is 50 degrees below zero, and that number stops being abstract the moment the air locks your lungs on the first breath. Your eyelashes freeze shut in 10 seconds. Bare skin does not go numb here. It blisters, it blackens, it dies. Somewhere in that darkness, a small group of human beings, no jackets, no heat source, no emergency food, is trying to stay alive until morning. No thermometers, no science, just knowledge encoded in habit, passed down through generations in the specific way they moved through the world. Most of them make it to morning. And the reason has almost nothing to do with toughness, or fire, or willpower. It has everything to do with one thing most modern people would look at and see as nothing more than grease, animal fat. And the reason it worked is something that should genuinely disturb you, because these people understood the human body under thermal stress more precisely than most of us ever will. This is prehistoric shadows, and this is how humans conquered the coldest place on Earth. Before we talk about what they ate, we have to understand what they were actually fighting, because most people imagine extreme cold as a passive thing, a temperature you simply endure until it passes. But -50 is not passive, it is aggressive. It is physics, working directly against your body through every available channel, all at once, without pause. The core body temperature of a healthy adult sits at 37 degrees Celsius. In an environment of -50, that creates a gradient of nearly 90 degrees, pressing outward through the boundary of your skin. Heat always moves from high to low, from warm toward cold, from you toward the void outside. Every second you are alive in that environment, heat is escaping through 4 simultaneous channels. Conduction pulling warmth through your feet into frozen ground. Convection stripping heat from exposed skin with every gust of wind. Radiation bleeding infrared energy into the open air, even when the air itself is perfectly still. And evaporation, because every single breath you exhale is warm and humid, and the cold converts that moisture into ice and takes with it the energy that made it warm in the first place. Your body is not passively losing heat. It is being robbed of it, continuously, through every surface it presents to the world. And the only way to survive that robbery is to generate new heat faster than the environment can steal it. That is not endurance, that is thermodynamics. And understanding that distinction is the difference between survival and a slow, quiet shutdown. So if survival is an energy equation, heat out versus heat in, then the question becomes very simple. What fuel burns long enough and steady enough and hot enough to keep that equation balanced through days and weeks and months of Arctic winter? And this is where the answer stops being obvious, because the intuitive guess is wrong. The intuitive guess is protein, meat, the thing you hunt. But here is the problem. Protein burns fast and dirty. It spikes blood glucose, triggers an insulin response, and then drops. In an environment where your body needs a continuous, uninterrupted supply of thermal energy around the clock, a fuel source that oscillates is dangerous. It creates gaps. And in a gap, at -50, the body begins to lose the race. Fat is different. Per gram, it contains more than twice the caloric energy of protein or carbohydrates. But the real advantage is not the quantity, it is the release profile. When fat is broken down through beta oxidation, it produces energy slowly, steadily, in a way that does not spike and crash. As dietary carbohydrates disappear from the equation entirely, the liver transitions into producing ketone bodies, molecules that cross the blood-brain barrier and fuel cognitive function just as effectively as glucose, while simultaneously feeding muscle tissue and driving heat production throughout the body. This state nutritional ketosis is not starvation. It is not deprivation. It is a completely different metabolic mode, one the human body was literally designed to enter, built for exactly this kind of sustained low-temperature existence. In the Ice Age, fat was not food. It was heat you could eat. But even burning fat at peak efficiency is not enough on its own. That energy still has to be converted into heat fast enough to replace what the environment is continuously draining away. And this is where the story takes a turn that most people never expect, because the solution is not muscle, it is not shivering, it is a different kind of fat entirely. Brown adipose tissue looks nothing like regular fat under a microscope. Where regular fat cells are pale and simple, essentially just storage vessels filled with lipid droplets, brown fat cells are dense, dark, packed with mitochondria, and threaded through with blood vessels. They are not storing energy, they are burning it. Through a process called non-shivering thermogenesis, brown fat bypasses the normal pathway of converting energy into ATP for cellular work, and instead releases that energy directly, immediately, as heat. It is a metabolic short circuit, a furnace that runs on fat and produces nothing but warmth. But here is the thing that makes this even more remarkable. Brown fat activation is not fixed. It responds to cold exposure. It responds to diet. In populations that lived in extreme cold environments for thousands of generations, this system became more sensitive, more responsive, and more integrated with the rest of the body's thermal regulation than in populations that never faced that pressure. For Ice Age humans, it functioned as a second layer of internal heating running quietly behind the scenes, burning fat without demanding movement, keeping core temperature stable through the coldest hours of the night when every other heat source had gone dark. And even this, as it turns out, was not enough on its own, because the system was about to encounter a trap that had nothing to do with cold. This is the part of the story where everything most people assume about survival gets inverted, and it is the detail that, once you understand it, reframes everything that came before. Lean meat, the thing every instinct tells you to hunt, to prioritize, to eat as much of as possible, can kill you in extreme cold, not through contamination, not through spoilage, through a biochemical failure so specific and so counterintuitive that 19th century Arctic explorers died from it without ever understanding what was happening to them. It is called protein poisoning, and it works like this. The human liver can process a limited quantity of protein per day, roughly 200 to 300 grams, depending on body mass. Beyond that threshold, the liver cannot convert the excess nitrogen from protein metabolism fast enough, and toxic byproducts begin to accumulate in the bloodstream. The result is a body that is eating, that is consuming calories, that feels like it is being fed and is still metabolically failing. Nausea first, then fatigue that does not respond to rest, then cognitive decline, then a slow, confused deterioration that looks like starvation even though the stomach is full. European explorers in the Canadian Arctic, in Siberia, in the extreme north, they documented this over and over in their journals, in their expedition reports, in their letters home. They hunted rabbits. They hunted lean caribou. They ate until they could not eat more, and they wasted away. The Inuit communities who watched this happen understood it without needing the biochemistry. They had lived with this knowledge for thousands of years. You did not go after the lean animal. You went after the fat one. You passed on the rabbit. You waited for the seal. You cracked the bones open while the animal was still warm and pulled the marrow out with your fingers, because the marrow, dense, gelatinous, almost electric with energy, was the prize. Not the muscle, never just the muscle. In the Ice Age, fat was not a preference. It was survival intelligence built into behavior, passed from parent to child, refined over generations until it was as automatic as breathing. And this is where the prey themselves become part of the architecture of survival in a way that most people completely overlook. The megafauna of the Ice Age were not just food sources. They were energy reservoirs, living batteries that had spent hundreds of thousands of years evolving to store the exact kind of fuel that Ice Age humans needed most. A woolly mammoth in late autumn, after a full season of grazing on calorie-dense Arctic grasses, could carry subcutaneous fat layers 20 centimeters thick in places. A steppe bison killed at the right time of year held enough rendered fat to sustain a small group of humans through 2 to 3 months of winter with nothing else added. Even the bones were part of the calculation. Bone marrow protected inside dense cortical bone that insulated it from freezing, even in extreme temperatures, remained nutritionally stable and accessible, with nothing more than a heavy stone. Ice Age hunters did not eat the muscle first and leave the rest. They did the opposite. They smashed the bones open immediately, while the carcass was still warm, and pulled the marrow out while steam was still rising from it in the freezing air. They consumed the organ fat, the deposits around the kidneys, the heart, the brain before the muscle tissue ever made it to the fire. And what they could not eat immediately they rendered, boiling fat down into a dense, shelf-stable form that could be stored, transported, rationed, and consumed across weeks or months. This single practice rendering and storing fat transformed a successful hunt from a temporary feast into a controlled energy strategy. It removed the daily uncertainty of survival. It built a buffer between the group and starvation. It turned hunting into infrastructure, not just sustenance. Generating heat internally is only half of the equation, because without a system to contain that heat, to hold it against the body and prevent it from radiating away into the Arctic air, even the most perfectly calibrated metabolic engine fails within minutes. And this is where the same animals that provided fat provided the second half of the survival architecture. Cold-adapted mammal fur is not just warm, it is structurally engineered by evolution over millions of years. The guard hairs of species like reindeer and Arctic fox are not solid fibers. They are hollow tubes, each one trapping a column of still air inside, dramatically reducing thermal conductivity across the outer surface of the garment. Beneath those guard hairs, a dense underfur layer creates a second zone of trapped air, effectively building two insulating chambers between the animal's skin and the environment. Ice Age humans understood this not through chemistry but through generations of use, through noticing which garments failed and which ones held, through surviving winters in one design and dying in another. They layered these furs deliberately. They oriented them with fur inward on inner layers to trap body heat directly against the skin, and fur outward on outer layers to shed wind and precipitation. They left controlled ventilation points at the wrists and collar to allow moisture to escape, because moisture was the hidden killer lurking inside an otherwise perfect insulation system. Sweat that accumulates inside clothing, saturates the fur, freezes against the skin, and destroys. The insulating air columns can accelerate heat loss catastrophically and cause fatal hypothermia in minutes, even when the person appears warmly dressed. What they designed was not clothing in the decorative sense. It was a wearable thermal management system, refined through the most rigorous testing environment imaginable. There is a dimension to extreme cold survival that almost never gets discussed, and it is arguably the most dangerous one. Not the cold itself, not the wind, not the lack of food, it is time. Specifically, the problem of what happens when the day ends and movement stops. During daylight hours, the body generates heat through activity. Muscles contract, metabolism accelerates, and the engine runs warm. But at night, when movement stops and the body enters sleep, metabolic rate drops naturally and significantly. The cardiovascular system slows, muscle activity ceases, the internal furnace banks its fire. And in an environment of -50 degrees, that drop in metabolic output creates a thermal crisis that no amount of willpower or conscious effort can resolve because you are unconscious. The insulation of your clothing becomes your only active defense, and the energy reserves your body can draw on during sleep become the backup generator that determines whether you survive until morning. This is where the timing of fat consumption stops being a dietary preference and becomes a survival decision with life or death consequences. Consuming a high-fat meal immediately before sleep does not just add calories to the daily total. It initiates a slow, sustained metabolic burn that releases energy gradually across 6 to 8 hours of digestion and processing, precisely the window of maximum vulnerability. Fat digests slowly. It asks the liver and the metabolic system to work at a low, steady rate for a long period. It keeps the internal furnace running at minimum viable output through the darkest, coldest hours of the night. Ice Age humans almost certainly understood this in practical terms without ever framing it scientifically. The last meal before sleep was the heaviest in fat. The timing was not accidental. It was the quiet engineering of a system where one wrong decision on one cold night did not give you a second chance. There is one more physiological layer to this system that most survival discussions completely skip, and it operates at the boundary where the body's defensive mechanisms start working against it. When the brain detects that core temperature is threatened, it activates vasoconstriction, a controlled narrowing of blood vessels near the skin and in the extremities to reduce the surface area through which heat can escape into the environment. This is the body attempting to protect its most critical organs: the heart, the brain, the lungs. It works, but it comes at a cost that compounds over time. The fingers begin to lose sensation, the toes stop responding, the ears feel like they have been replaced by wood. Blood flow to the extremities drops to the minimum necessary to prevent immediate tissue death, and then drops further. Frostbite is not an accident. It is the body making a calculated trade peripheral tissue for core survival. But here is where the system approaches its catastrophic limit. The heart must still pump. The circulatory loop must still function, because it is the mechanism by which every organ receives the oxygen and nutrients it needs to keep producing heat. And if energy reserves fall low enough, cardiac output begins to decline. The pump weakens, blood pressure drops. The extremities, already receiving minimal flow, receive even less. And the failure propagates inward, not outward, not slowly, but rapidly, in a cascade that accelerates once it begins. Maintaining sufficient fat input is not simply about staying warm in the way most people imagine warmth. It is about keeping the cardiovascular system above the threshold of functional collapse under conditions designed by physics to push it below that threshold. Without that energy, the system does not degrade gradually. It falls apart from the edges in, and it does so faster than most people realize is possible. Step back from the individual pieces for a moment and look at what we have actually been describing across these last several segments. Because this is not a list of survival techniques. It is not a collection of tips and tricks that Ice Age humans happened to accumulate over time. It is a single, unified, self-reinforcing system where every component depends on every other component, and the failure of any one of them cascades through all the rest. Fat intake drives the metabolic engine. Beta oxidation converts that fat into a continuous energy stream. Brown adipose tissue takes that energy and converts it directly into heat, bypassing the normal cellular work cycle. Ketone metabolism keeps the brain functional across weeks of near-zero carbohydrate availability. Hunting strategy, choosing fat prey over lean prey, accessing marrow and organ fat before muscle tissue ensures the fuel supply meets the metabolic demand without triggering the protein poisoning threshold. Rendering and storage transforms episodic hunting success into a stable, rationed energy reserve that can bridge periods of failed hunts or severe weather. Clothing architecture retains the heat that metabolism produces, preventing it from radiating away faster than the body can replace it. Timed fat consumption manages the overnight thermal window when metabolic rate drops and external protection is weakest. And cardiovascular maintenance through consistent energy availability ensures the circulatory system never drops below the threshold of functional collapse. Pull any single element out of that structure and the whole thing weakens. Pull several and it collapses. This is not primitive survival improvisation cobbled together in desperation. This is a system that was designed by 10,000 years of pressure, refined by the deaths of everyone who got it wrong, and perfected by the survival of everyone who got it right. And here's the part of this story that should genuinely unsettle you. Because this system did not just keep Ice Age humans alive. It rebuilt them biologically, permanently, in ways that you carry in your body right now, regardless of where you were born or how you live. The individuals who survived sustained exposure to extreme cold over multiple generations were not just the luckiest or the most resourceful. They were the ones whose physiology was most precisely aligned with the demands of the system. Those who could transition into ketosis efficiently and maintain it across weeks of high-fat, low-carbohydrate intake. Those whose brown adipose tissue activated faster and more completely in response to cold exposure. Those whose livers could sustain ketone production at the levels required for cognitive function through months of thermal stress. Those whose cardiovascular systems maintained output under conditions designed to compromise them. These individuals survived. They reproduced. Their descendants inherited those traits at slightly higher frequencies. And over tens of thousands of years of relentless selection pressure, the cumulative effect of that process reshaped human metabolism, human thermal regulation, human fat storage architecture, in ways that are still detectable in populations today. The cold did not simply challenge human beings, it edited them. It ran the most ruthless optimization process in biological history, a test with a pass rate that declined every winter and a curriculum that never changed. We are the result of the students who passed, and we carry their answers in every cell. So when you come back to the original question, how did humans survive 50 degrees below zero with nothing but animal fat? The answer is that fat alone was never the whole story. It was the center of a system, the axis around which everything else rotated. The animals were not just food. They were living energy infrastructure, co-evolved alongside the cold for longer than our species had existed. The clothing was not just covering, it was thermal architecture, engineered to hold heat through the hours when generating new heat was impossible. The hunting strategy was not just acquisition. It was pharmaceutical, a precise understanding of which tissues provided survival and which ones, in excess, caused death. And the fat itself was not just a calorie source, it was the technology, the most sophisticated technology those humans possessed. Simple and primitive are not the same thing. What those people understood about the human body was as deep and precise as anything we have developed since, just encoded differently. Not in textbooks, in behavior. In the specific way a hunter cracked open a femur 40,000 years ago, pulled out the marrow while steam was still rising from it into the Arctic air, and knew without being able to explain why that this was the thing keeping them alive. In the Ice Age, fat was not food. It was heat you could eat. And everything else was built around that single extraordinary fact. If this kind of story pulls at something in you, subscribe to Prehistoric Shadows. There is so much more beneath the surface, and we are just getting started.